Nintendo Switch Lite. You see what's going on? The port looks a little suspect, but not a whole lot going on in there. It's got a few little pieces of debris, but nothing alarming. Alright, let's plug it into power. Take a look on the left-hand side, leftmost meter, PCU channel 1. And we're drawing 0 amps on both sides. So that could be port or M92T36 or possibly BQ24193 or the port fuse. So we won't really know until we get it open and get it apart and do some testing. This video is brought to you by PCB Way. Click on PCB Instant Quote and you will be met with a ton of selection options. Options like layers, starting at 1 layer all the way up to 14 layers. Many material options, solder mask and silk screening colors, and much more. Check out my affiliate link in the description for a $5 coupon off your first order. And now back to the repair. Okay, we have the board out of the housing and we're preparing to do some tests here. And we're going to start our testing around the M92T36 as always. Find ourselves a ground, which case can be the port. And we'll test around this M92T36. Same rules apply. If it has 1 line to the IC from a capacitor, we're just going to test the capacitors. If it has 1 line to the IC, we do not want that line to be shorted to ground or have a pathway to ground. Accidentally touched the other side of that capacitor. Okay, we don't seem to have any. Now this one has 2 lines, so one side of that will be ground. Okay, we do not seem to have any shorts going around the M92T36. Let's check our BQ24193. First thing I want to check is this big coil. No shortage, but we do have continuity. Okay. And everything looks good around the BQ. So let's check up here around these MOSFETs. Nothing. Okay. Nothing. Nothing. Alright, let's check this invincible fuse. It's still being invincible. Okay. Well, interesting. So we're pulling nothing. And we got no shortage. Okay. See if we're getting the same behavior out of the housing as we were in it. I'm still getting nothing, so I'm very much suspecting the port here. Yeah, we're drawing absolute 0. Don't see a whole lot going on in there, but okay. That is a little loose. This should not move at all. Even with the bent pins in there, this moves not even a little bit. The whole port will move with it. That center plastic is a little bit loose, so I would say it has been torqued and broken. Yeah, maybe broken up in here on the plastic. So pretty good bet that this port is bad. We're going to pull it off, set up to pull it off, and go from there. Okay, we set up to remove the port. Before I remove the port, let me throw up my expected temperatures for this job. These are my expected temperatures for this job. As always, they are subject to change as the job changes. I don't foresee a point in which the job would, job would change unless I have to reball an IC, in which case I'd probably drop the hot air to 380 just for the reball. But other than that, everything should be dead on pretty much for a switch. As always, these temperatures are brought to you by the Amazon Associates links in the descriptions. If you click on any of those links and buy any of that equipment or buy anything during that particular session, a small portion of that purchase will go to supporting the channel and be greatly appreciated. It will not cost you an extra dime. Switch you to microscope. Alright, let's remove this port. We're going to first apply some low melt to the anchors, just to make things move a little bit easier. It also will assist us in cleanup. We don't like it when we get slippage. We get a little nut on other things we did not want a little nut on. As this port has been broken a little bit on the inside, I am going to be careful about removing this one, as it may have torqued the pads. And by careful, I mean I don't want it to just blow off the board. We'll just kind of gently get it off the board. Okay, it wants to be removed now, and we'll pull it gently. Nice clean pull. Excellent. Okay, looks like we've gotten reasonably fortunate here. By reasonably fortunate, I mean we have no pull pads. Here's where the magic of low melt assists a great deal. Plus a nice big tip. I'm just going to glide over these pads very carefully. You don't want to put pressure on them. This is not a scrubber. Clean it off and have a look. My apology if the picture has a little bit more wobble to it when we're under a microscope. Getting an articulating arm stopped being something I wanted and started becoming a necessity. So with an articulating arm, you will get some more wobble. Any little vibration will make it move. Just one of the drawbacks, but the positives far outweigh the negatives at this point. It has taken some getting used to, though, for me. Okay, as always, our next issue is the fact that the Nintendo Switch Lite port, this one here, is physically shorter than the Nintendo Switch port. You can get the Lite ports, but they're pools, and I don't trust other people's pools, so I will not use their pools. So what I have to do is I have to pull out my Dremel, and I have to grind down the Nintendo Switch port to fit the Lite. And basically what I use as my guide is these two tabs on the Nintendo Switch port. And if I can get it pretty close to even to those two tabs, it'll be pretty close to being a match to the Switch Lite port. You'll be able to get, the reason why I do ground it down, you can get the back cover on over the bigger port, but the problem comes if you ever have to take that back cover back off. It is, you will play hell doing it. It's not fun. So I always recommend grinding it down. You do have to clean it off and clean it out very thoroughly if you grind it down, because you do not want metal shavings in the port. So there's a lot of things you have to pay attention to if you take this method, but to me it is the preferred method. And as you can see now, we are pretty close to an exact match as far as height, and this will allow us to get the back cover on with ease and off with ease. Okay, let's place the port. Okay, now I need to protect the fan connector and the LCD connector because I always heat from above, so we will place an old iPhone shield on top with a little bit of additional protection. Copper shim. Lots of things to absorb heat. And then we'll use our normal method to flow in the port. Rapid air movement, rapidly moving the nozzle so that we're never in one place for very long. And what we're doing is bringing up the temperature of the board and using that temperature to wet the solder rather than directing the heat or using the heat, direct heat. And we're just watching for the visible pins to wet. And we want them all to wet. Okay, we're getting some wetting now. Be patient. And the port did kind of sit down. Now we're going to concentrate a little bit in the hidden area because we have more to go through on that one. And then we're going to hold the port down, moving the heat. And wait for the solder to dry. We're going to hold it a little bit longer because, again, the hidden pins are under quite a bit of stuff that will remain hot for longer than the stuff that's out in open air. Okay, now we're going to perform our little nudge test. And we should get no play here. If you only solder the outside row, you'll get a little bit of play. If both rows are soldered, you won't get any. And that feels pretty solid. Excellent. And let's check our connectors and make sure we didn't damage those. And perfect. Excellent. Solder our anchors. Flux and solder are in the description, as is everything else of note. Want to get good feed through, ideally on these. See how we did? And perfectly acceptable. Okay, we're going to clean this board up thoroughly, and particularly the port. I'm going to use my air compressor just to make sure that there's no possibility of metal shavings being in the port. I do not want to stick power to it right at this moment. So we'll clean it off and we'll come back and perform some tests. Okay, we're ready to perform some power tests. We have our channel 1 on. And just want to see if our behavior has changed. We would like to see something other than 0 amps. And we're not seeing anything at all. Well, not cool. Okay. I don't know if there's a point in doing the battery test, but we'll try it. Nothing. Not ideal. Okay, we're still getting nothing. Let's test again, because that is not making a whole lot of sense. Okay. made contact with the ground side of that capacitor. Nothing is abnormal. I wonder if these test pads, well, that's definitely ground. I wish I knew the test pad layout of the Switch Lite. Our BQ area again. I guess the chip could be one of the chips could be bad without showing. Ground. Doesn't look like a ground. Does not look like a ground. You can see that little via going right up there. Does not appear to be a ground to me. This is ground. No, it could just be a big power line too. But it seems to connect all the way to ground, so that's ground. This is definitely separated, but it's shorter to ground. I wonder if that might be an indicator that our M92 is done. Alright, we're going to go out to the M92 and then we'll test that test pad to see again. Yeah, we'll test that test pad. I really would like to have another indicator if the M92 is bad like we have on the normal Switch. Sometimes you can test the test pads on the Nintendo Switch regular, and even if one of the capacitors around the Switch is not bad, those test pads will test out bad. So, well, let's check and see. Because at this point we're kind of in a mystery mode where we're going to have to kind of do some educated guessing. You know, 0.0 amp draw on the Nintendo Switch regular is usually port, fuse, M92 T36 or BQ24193 in my experience. There isn't much else that causes it. The light is different, but it's not that different. So let's give the M92 T36 a try. We'll pull it and then I'm going to test that test pad on the other side just to see. Let's test that pad again. And no short. So we'll put another new chip in and see if that pad comes up short again. It could be connected naturally to ground. I doubt it, but we'll see. A new chip on. Trying to direct the heat away from the port. And we have reworked the port. Okay, center pad is wetted. Drop the chip. Make sure it makes contact with that center pad. Shoot. Okay. Move the heat. Hold the chip down. Reapply. Move the heat. We'll make sure we did not disturb our port. Everything was connected. Let's check and see how we did on the M92T36. Want alignment to be pretty close to dead on, but it doesn't have to be perfect. Need every pin connected though. And it looks pretty good. For grands, we want to test that pad again and see if it is short to ground again. See if we're onto something or not. And it is not shorted to ground. We may have found a good test pad for our M92T36. Let's try a power test. Hello. That looks like normal behavior to me. Let's try the other side. Hello, that is good news. Alright, we'll try our batter squid. Alright, let's activate and see. We're looking at channel 2. And we just want to see a steady climb in amperage. Very good, not getting hung up. Excellent. Okay, to reiterate, we tested the test pads. We don't really know the test pad layout of the Nintendo Switch Lite. But we flipped over the board and we tested this pad right here. And as you can see, there's a via leading to this pad. It is not a ground pad. It is surrounded by ground, but it is not a ground pad. And it should not have read short to ground. It did read short to ground. And this led me to believe possibly this might be an indicator of M92T36. So we removed the M92T36. The short was removed. And we replaced the M92T36 and the short did not come back. So that might be a great indicator for us to test these pads here. This one would definitely be ground, but these guys with lines linking to them should not be shorted to ground. So, and this one should not be either. So, hopefully, these guys will help us find the M92T36s like this one that did not show short on any capacitor. Okay, as you can see, we're back up and running. We are pulling 15 volts, 0.74 amps on the USB charger. Now this USB meter only works in one way, so we're going to have to pull this out and test both side charging on the PSU. So take a look at PSU channel 1. Okay, and we're fast charging on PSU channel 1, that side. We'll check the other side. And fast charging on both sides. Excellent. Alright, we'll just run through a few little basic tests. Make sure this Joy-Con in particular is the one you gotta test because you have to pretty much disassemble it to get the board out. So just make sure everything is working. Alright, everything appears to be working. You can go down to settings. And make sure we're picking up our internet. And we are. Very good. And that's really all the tests I can perform. I accidentally gave away my game with one of my repaired consoles, so I can't really test the game card reader. This is for a shop client anyway, so they'll do all that testing anyway. Okay, we actually made a pretty interesting discovery in this particular video. And guess what? I'm not going to tell you if you fast forward here to get the spoiler. Sorry about it. Go back and watch the video. If you need this type of repair executed, take a look in the description below or stick around for the end cards. And if you enjoyed this video, take a look at that one. And I'll see you there.